16 miles in circumference underneath Geneva. We accelerate protons, which are these simple particles, to 99.999999% the speed of light.
The earth-shattering feeling you just experienced is what some might call the Mandela effect.
Scientists at CERN are at the edge of their seats, eagerly anticipating breakthroughs from the world's largest and most powerful particle accelerator. The Large Hadron Collider, a marvel of modern science crafted by the European Organization for Nuclear Research, has shed light on numerous scientific puzzles. Just now, Brian Cox has announced that something terrible has happened at CERN that no one can explain. During a test with unprecedented energy levels, CERN scientists encountered something unexpected and potentially unsettling. Could this discovery provide more insight into the universe's secrets like miniature black holes? And how is this discovery related to the Mandela effect? Let's find out why this mystery has left even the most seasoned researchers scratching their heads. Deep beneath the borders of France and Switzerland lies a marvel of modern science, stretching an impressive 17 miles in a circular path. This is the Large Hadron Collider, a giant ring made up of superconducting magnets. It is specifically designed for accelerating particles that are invisible to the naked eye. The Large Hadron Collider is famous for its groundbreaking discoveries. Here, scientists have managed to peek into the world of tiny particles, unlocking secrets that have puzzled us for decades. One of its most famous achievements is the discovery of the Higgs boson, often called the God particle. This discovery was profoundly significant because the Higgs boson was the last missing piece in our standard model of particle physics, a theory that explains the fundamental building blocks of everything around us. And recently, a new shocking discovery made in CERN has been announced by Brian Cox that has left scientists confused and shocked. But why is the Large Hadron Collider so important? It's not just about finding new particles. The real magic of the Large Hadron Collider is its ability to recreate conditions that existed just moments after the Big Bang, the massive explosion that gave birth to our universe, according to scientists. By smashing particles together at nearly the speed of light, the Large Hadron Collider mimics these ancient conditions, giving us a glimpse into how our universe might have looked and behaved in its very first moments. It's like having a time machine that takes us back to the start of everything, helping us understand the origins and evolution of the universe. In the aftermath of World War II, when the world was still feeling the tremors of conflict, a group of visionary scientists had a bold idea. They wanted to create a place where knowledge was king, where the ruins of war could give way to collaboration and discovery. This idea gave birth to CERN, the European Organization for Nuclear Research. Established in 1954, CERN was more than just a laboratory. It was a symbol of hope, a testament to what humanity could achieve when we worked together for the greater good. Over the years, CERN has grown from a post-war dream into a powerhouse in the world of particle physics. It's become a hub where the brightest minds from all corners of the globe come together to unravel the mysteries of the universe. CERN's flagship project, the Large Hadron Collider, is a prime example of its evolution and significance. This sophisticated facility has allowed scientists to test theoretical models, challenge established assumptions, and push the boundaries of scientific knowledge for years. What started as a small group of countries banding together for the sake of science has expanded to include 23 member states and thousands of scientists. CERN has been at the forefront of some of the most groundbreaking discoveries in physics. From uncovering new particles to developing technologies that have applications far beyond the lab, CERN's journey has been one of relentless pursuit of knowledge. One of the most important parts of the Large Hadron Collider are its magnets and the cooling systems. These aren't your average fridge magnets or air conditioners. The Large Hadron Collider uses superconducting magnets, and there are a lot of them. We're talking about thousands of magnets, some bending the path of the particles, others squeezing them closer together to up the chances of collisions. These magnets are superconducting, which means they can conduct electricity without resistance, but only under super cold conditions. This is where the cooling systems come into play. They keep these magnets at a mind-boggling 456 degrees Fahrenheit. That's colder than outer space. But why is it so cold? Because at these temperatures, the magnets can operate in a superconducting state, efficiently steering and accelerating the particles around the Large Hadron Collider ring with amazing precision. When you think about the Large Hadron Collider, imagine a gigantic, incredibly cold ring with superconducting magnets working in harmony to race particles around at breakneck speeds. It's this combination of size, temperature, and magnetic precision that makes the LHC not just a feat of engineering, but a kind of scientific symphony, with each component playing its part in perfect harmony. This is what makes the Large Hadron Collider capable of revealing the universe's deepest secrets. And its most recent discovery has changed our understanding of modern physics as we know it. A former researcher at CERN and a well-respected voice in the field, Brian Cox has a deep connection with the Large Hadron Collider and its explorations into the unknown. Recently, Cox stepped into the spotlight with an announcement that has sent ripples through the scientific community. He revealed that something unexpected and alarming had been detected at CERN. It's not every day that something leaves these seasoned scientists scratching their heads, and that's precisely what's happened here. According to Brian Cox, scientists at CERN have been able to replicate the Big Bang within the Large Hadron Collider. This successful experiment could open up new avenues for CERN, as they can now reveal secrets of how exactly our universe was created. However, this announcement was met with alarm. While this possibility is exciting for scientists, many like Brian Cox are terrified of the many ways it could go terribly wrong. Like any journey into the unknown, there are potential risks and concerns associated with these high-scale experiments. First off, let's talk about what it means to explore the unknown at a place like CERN. These experiments, especially in the Large Hadron Collider, deal with energies and particles that, until recently, were the stuff of theory. Tinkering with the fundamental building blocks of the universe could, theoretically, have unexpected consequences. It's like opening a door without knowing what's on the other side. The majority of scientists believe that the experiments are safe, but the element of uncertainty in groundbreaking science always carries a degree of risk. A stark reminder of these risks is the incident involving Russian scientist Anatoly Bugorsky. Back in 1978, Bugorsky was working on a particle accelerator when he accidentally exposed his head to a proton beam. Miraculously, he survived, but the accident left him with severe injuries. This incident, while not directly related to CERN's activities, highlights the potential dangers inherent in working with such powerful machines and high-energy particles. Another danger that often comes up is the creation of miniature black holes. Some theories suggest that the intense collisions in the LHC could create tiny black holes. While this sounds like a plot from a sci-fi movie, scientists have assured that even if these black holes were to form, they would be incredibly unstable and would likely evaporate almost instantly due to a phenomenon known as Hawking radiation. The chance of a stable, dangerous black hole forming is astronomically low, but the very idea stirs up a mix of awe and apprehension. The reaction from the scientific community has been a mix of intrigue and concern. There's a buzzing curiosity about what this discovery could mean for our understanding of particle physics and the universe. At the same time, there's a hint of apprehension because, in the realm of high-energy physics, the unknown can sometimes be a Pandora's box. This blend of excitement and caution is typical in science when we're on the brink of potentially groundbreaking discoveries. Scientists from around the world are eagerly awaiting more information, ready to decipher this mysterious finding. In academic circles and research labs, conversations are abuzz, speculating on the nature of Cox's announcement and its implications for the future of particle physics. The Mandela effect is a term that refers to a situation where a bunch of people remember something one way, but it turns out to be incorrect. It's named after Nelson Mandela because a lot of people remembered him dying in prison in the 1980s, when in fact he was released and passed away in 2013. It's like your memory playing tricks on you, but on a bigger scale where lots of people have the same false memory. What's this got to do with CERN? Here's where things get really interesting. Some people speculate that the high-energy experiments at CERN, particularly with the Large Hadron Collider, might be causing ripples in the fabric of reality. Imagine CERN's experiments are so powerful that they might be opening tiny cracks or doorways to parallel universes. This is purely speculative, of course, but it's a fun idea to ponder. There is a theory that speculates if there are parallel universes, maybe our world is brushing up against them. And in the process, some people's memories are getting mixed up with experiences from these alternate realities. That's where the Mandela effect could come into play. It's as if CERN is unintentionally causing these memory crossovers, giving us glimpses into alternate versions of history that exist in parallel universes. Now, it's crucial to note that this is all in the realm of speculation and theory. Scientists at CERN aren't actively trying to punch holes into other universes, and there's no concrete evidence to support these ideas. But what if the Mandela effect is more than just a quirk of memory? And what if CERN's groundbreaking experiments are opening doors we never knew existed? This is where string theory comes in. In the simplest terms, string theory suggests that the most basic building blocks of the universe aren't tiny particles, like atoms, but are actually really small strings. Imagine tiny vibrating strings everywhere, and the way these strings vibrate determines what kind of particle they become. It's like everything in the universe is made up of these little strings playing their own unique tunes. Where things get even more mind-bending is when we talk about parallel universes. String theory opens the door to the idea that we might have extra dimensions, way more than the 3 dimensions we're used to. According to string theory, these extra dimensions could be tightly curled up, so small that we can't see them. But they're there, making the universe a lot more complex than we ever imagined. String theory also hints towards the idea of parallel dimensions. String theory hints that these extra dimensions could be the places where parallel universes exist. Our universe could just be one layer in an enormous cosmic cake, and these extra dimensions are like the ingredients that make up the other layers. Each layer is a different universe, existing alongside ours but in a different dimension that we can't easily access. This is all theoretical, of course. We haven't actually seen these extra dimensions or parallel universes, but string theory gives us a framework to think about their possibility. It's like a giant cosmic puzzle, and string theory is one way we're trying to solve it. Scientists, including those at CERN, are looking into these ideas, trying to find any evidence that could turn this theory into reality. It's an exciting, if somewhat daunting, frontier in our quest to understand the universe. One of the many mysteries of the world that CERN has been exploring is the idea of hidden dimensions. Gravity, that force that keeps our feet on the ground, is something we experience every day. But here's the kicker. Even with all our scientific advancements, gravity still holds a lot of mysteries. We understand how it works, like how it keeps the planets in orbit. But why it works the way it does is still something of a puzzle. It's the weakest force known in the universe, yet it has an immense influence on a massive scale. Some scientists are playing with a fascinating idea. What if gravity is linked to hidden dimensions? This isn't sci-fi. It's serious scientific speculation. The idea is that gravity might not just be limited to the 3 dimensions we live in. Imagine our universe as a multi-layered cake. We're on one layer experiencing life in 3 dimensions. But what if there are more layers to the cake? Layers we can't see. These hidden dimensions could be really tiny, all curled up so we don't notice them. But gravity might be sneaking into these dimensions. That's one reason why it could be so weak compared to other forces. It's spread out over more dimensions than we're aware of. The Large Hadron Collider at CERN is like a high-tech tool trying to probe these extra dimensions. If they find evidence of these hidden dimensions, it could change everything we know about physics. It's like finding a secret room in your house that you never knew existed. It's an exciting idea that could explain some of the biggest mysteries in physics, like why gravity is so different from the other fundamental forces. So, while we're all familiar with gravity, it might be doing more than just keeping us grounded. It could be our ticket to discovering entirely new aspects of the universe. This isn't the only mind-bending mystery that scientists at CERN are exploring. Quantum entanglement is a curious phenomenon in the quantum world, the world of really, really tiny particles. Imagine two particles that are so deeply connected that if you change something about one, the other one changes instantly, no matter how far apart they are. It's like having two magic dice, where if you roll a 6 on one, the other one, even if it's miles away, also shows a 6 at the exact same moment. Now, how does CERN come into the picture? Scientists at CERN are using the Large Hadron Collider to study these quantum entanglements. By smashing particles together at crazy speeds, they can create conditions where they can observe and experiment with quantum entanglement right there. This has huge importance as understanding. Quantum entanglement could be a game-changer in figuring out some big mysteries about space and time, and maybe even other dimensions. It's like having a puzzle with missing pieces, and quantum entanglement might help us find those pieces. The experiments at CERN could give us clues about how space and time are woven together in the fabric of the universe, and whether there are other dimensions hidden from our view. While quantum entanglement might sound like a bizarre concept, the research happening at CERN could bring us closer to unlocking secrets of the universe that we've only just begun to explore. Let's not forget that CERN's impact stretches far beyond the realm of particle physics. This scientific giant has also sparked some pretty incredible technological advancements that affect our everyday lives. CERN's research has played a key role in the development of positron emission tomography scans. These are the machines used in hospitals to detect diseases like cancer. Positron emission tomography scans use a type of particle physics to create detailed images of what's happening inside your body. The technology behind these scans was developed in the same environment where scientists are busy unraveling the mysteries of the universe. It's a perfect example of how high-level science can lead to practical tools that help save lives. But perhaps the most astonishing contribution from CERN is something we all use every day: the World Wide Web. Yep, the web was born at CERN. In 1989, Tim Berners-Lee, a British scientist working at CERN, invented the World Wide Web. The initial idea was to create a way for physicists around the world to share their research easily. Little did he know, he was laying the groundwork for the internet as we know it today. A global system that's transformed how we communicate, work, learn, and play. From online shopping to streaming videos, the web has fundamentally changed our world. So while CERN's primary focus might be on particle physics and probing the depths of the universe, its impact is far-reaching. From healthcare technology to the digital revolution, CERN's contributions have left an indelible mark on various aspects of modern life. It goes to show that sometimes exploring the mysteries of the cosmos can lead to discoveries that change our day-to-day lives in the most unexpected ways. While the research at CERN is pushing the boundaries of human knowledge in exciting ways, it's not without its risks and ethical debates. It's a balance of exploring uncharted territories in physics while being mindful of the potential implications and responsibilities that come with such powerful technology. The announcement by Brian Cox has opened a new chapter of intrigue and speculation, highlighting the profound impact and occasional uncertainties of CERN's pioneering work in particle physics. Thanks for exploring with us on Beyond Discovery. If you enjoyed these revelations, click now on the next video that pops up on your screen. It's unbelievable.